Welcome to The Explainer. Today, we're going to pull back the curtain on a piece of technology that's so fundamental to our digital lives, it's practically invisible. We're talking about databases.
So let's start with a puzzle. Think about it. In a massive hospital with thousands and thousands of patients, how on earth does a doctor pull up one single person's entire medical history in just a few seconds? I mean, without the right system, that would be total chaos.
The answer, you probably guessed it, is a database. At its very heart, a database is just a structured way to hold data. It's the thing that takes a chaotic, messy pile of information and turns it into a perfectly organized, instantly searchable digital system. It literally creates order out of chaos.
Okay, so how do we actually create that order? Let's stick with our hospital example for a minute and walk through exactly how we would build the perfect digital filing cabinet to keep track of every patient. We'll start simple. Just imagine the entire database is like the hospital's big records room. Now, we're not going to worry about the whole room just yet. We're going to focus on just one single filing cabinet inside of it, a single table database that we'll call patients.
And this is what it looks like. In database speak, we call this a table. Think of it as our digital filing cabinet. The most important thing to see here is the structure, right? It's all organized into these neat columns, and each one has a super clear label for every piece of information we need, like first name or ward number.
All right, let's look inside this digital cabinet, because there are two fundamental building blocks to any table. This is where the real organizational power comes from. First up, you have what's called a record. A record is simply one complete entry. It's all the information about a single person or a single thing. So in our hospital analogy, a record is one complete folder for one patient. It's got their first name, their last name, their admission date, everything we need, all bundled together. And when you look at the table itself, this concept is so straightforward. Each individual row, that represents one complete record. So one row equals one patient. It's that simple. The second building block is the field. Now, a field is just one single piece of information within a record. So if the patient's whole folder is the record, a field is just a single labeled line inside that folder, like first name, Winnie, or ward number, 7. And looking at the table again, you can see how this all just clicks into place. While each row is a record, each column represents a single field across all of those records. So the first name column holds the first name for every single patient. And there you have it, records and fields. That is the fundamental anatomy of a database. Now, having an organized structure is great, but it's not enough. A truly great database has rules. These rules are absolutely crucial for preventing mistakes and making sure that the data we're storing is clean, consistent, and, actually makes sense. So why do we need rules? Well, for a few key reasons. We have to define the type of data. Is it text, a number, a date? We also need to validate the data to make sure it's logical. And, this is a big one, we need a way to guarantee that every record is unique, so we never, ever mix up two patients. And we do that with something called a primary key. Here's a perfect example of validation in action. We can set a rule that says the ward number field must be a number from 1 to 10. So if someone comes along and tries to enter 67, like you see happening here, the database just rejects it. It flags an error. The system itself enforces its own rules.
So what about two patients with the exact same name? This is where a primary key is so essential. It's a special field that has to contain a unique value for every single record. So for a patient, their unique hospital number is a perfect primary key. That number guarantees we can always find the correct Winnie Singh, even if there are two of them in the hospital at the same time.
Okay, so we've built this beautiful, organized, rule-based digital filing system. All the data's in there, it's clean, it's structured. Now for the most important part, how do we get specific information back out? Right, because we can't just walk into our digital records room and casually ask for what we want. We need to talk to our hyper-efficient, but let's be honest, very literal digital librarian in a language that it actually understands. We have to be precise.
That language is called SQL, which stands for Structured Query Language. You can say SQL or you can say SQL. You'll hear people say it both ways. It is the universal standard for asking questions, or as they're officially known, writing queries to get information from a database.
So let's see how you actually build a query. And don't be intimidated by the name. At its core, a basic SQL query is a lot like just forming a simple sentence. It has a very clear, very logical structure.
A basic query really just has three parts. First, you select, and that's where you say which fields or which columns you want to see. Second, you say from, and that's where you tell it which table to go look in. And third, you use where, and that's how you filter all the records down to only get the ones that match your specific criteria.
Let's put it all together. Imagine a doctor needs a list of every patient that's assigned to Mr. Smith. The query would be, select the patient's hospital number, first name, and family name from our patient table, where the consultant's name is Mr. Smith. And look at that. The database returns exactly that information, and nothing more. It's a precise answer to a specific question.
And that right there, that is the powerful relationship at the heart of every single database. The clearer your question, the more precise your answer will be. That's the whole point of this, being able to ask incredibly complex questions of huge amounts of data and getting back exactly what you need almost instantly.
And once you understand this basic idea, you are going to start seeing databases everywhere. Every single time you sort products by price, or you filter your email inbox by sender, or you get that perfectly tailored social media feed, you're querying a database. You're asking a question, and you're getting an answer. So, now that you know the secret, what will you see differently?